A Mexican restaurant's 3 best-selling dishes are nachos, taco salad bowls, and regular tacos. All 3 dishes use a particular amount of cheese, but the boss hasn't told you how much should go into each. He has just given you the total amount of cheese used over the last 3 days. And so that information is given below. So we want to use this information to write a system of equations and solve the system to find out how many grams of cheese each recipe uses. Then describe geometrically what the system looks like. So just that same question and same information is at the top, but I've got some space to work now. So the first thing I want to do is, because my calculator or my solver is going to only interpret X, Y, and Z, I want to turn nachos, taco salad bowls, and regular tacos into X, Y, and Z. So I might say that X is nachos, Y is taco salad bowls, and Z is regular tacos. And then when I write my equations now, let's say for day 1, I can write it in terms of X, Y, and Z. So I would have 24 nachos were sold, 33 taco salad bowls, and 50 regular tacos. And after all that, that amounted to 33,600 grams of cheese. Similarly for day 2, now I want to keep things in order. I still want X, Y, Z in this order. It's going to be useful for later, and you'll see soon. And it doesn't matter that they're in different orders up here. I can just rearrange them. So I'm going to put my nachos first, so it's 15X, then my taco salad bowls for 22Y, and finally 40Z, which is my regular tacos, and in that 23,900 grams of cheese was used. And then finally for day 3, again I want X, Y, and Z in that order. My nachos are 30, my taco salad bowls is 10, and my regular tacos is 29, and a total of 25,700 grams of cheese. Now that I've got my system, this is essentially a set of constraints, and each one of these equations represents a plane of coordinates, X, Y, Z coordinates, that satisfy those conditions. And so we can have a look here at those different planes. So if I just put this first one, so this is the plane that represents all the coordinates that satisfy the first equation, day 1. I can put in day 2, and as you can see, there is a bit of an overlap. There is a line going across where they intersect. So any coordinate on that line will satisfy equation 1 and 2. And if I put in equation 3, there's actually a single point here in the middle, if I put it there, where all 3 of these planes intersect and overlap. And whatever that coordinate there is in the middle, that satisfies all 3 of the conditions of each of the equations. And that's what we're looking for. Now, it's a bit hard to read off the graph, so I can use a solver to help me with that. And this is where having X, Y, and Z in that order is really important, or really useful. So I just type in my values from my 3 equations, which I came up with in the PowerPoint. So I'll just type these in now. And when I solve, I'm going to get my unique solution for the set of equations. So X is 500, Y is 200, essentially, and Z is 300. So if I go back to my PowerPoint, X is 500, Y is 200, and Z is 300. So what that means is, what we've solved is the amount of cheese for each of the recipes. So X is 500, meaning that a nachos recipe uses 500 grams of cheese, and so on. Taco salad bowls use 200 grams of cheese, and regular tacos use 300 grams of cheese. So geometrically, just this last sentence down the bottom, geometrically, this is a system where 3 planes all intersect at a single unique point, and this is the single unique point, 500, 200, 300, that we saw over here, if I go back, right in the middle. And that's it.